Okay, so in this video, I'm going to briefly explain how to use the quadratic formula to solve quadratic equations. It's really just as simple as putting in the numbers where they go. So first things first, to use a quadratic formula, again, we emphasize, you've got to be in standard form, right? And you're going to use the numbers A, B, and C uh, accordingly in the actual formula, which says that x of any quadratic equation, x is going to be equal to negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2 times a. Okay, and this is the case for any quadratic. The quadratic formula, like completing the square, works on any quadratic equation that you have to help you solve it. Whereas, the methods of factoring and whatnot don't always, they're not always applicable. Okay, so let's start with this first example here. And this one's relatively simple. The only problem is we are not in standard form. So real fast, let's rewrite so that we are in standard form. X squared minus 2x minus 1 equals 0. There we go. Now we're in standard form. So we see that a is 1, b is negative 2, c is negative 1. Right? And I'm going to plug those numbers in exactly where they belong. So x is going to be equal to negative b, so that means instead of negative 2, it's going to be positive 2, plus or minus the square root of b squared, so b squared 2 squared, we know that's just going to be 4, minus 4 times a and times c. All of that divided by 2 times a, which we know is just 1. Okay, so I've put all the numbers where they belong, and now I'm just going to do the math. Okay, so 2 squared is 4, right? So that's going to leave me with 2 plus or minus square root of, so 4, and then it's going to be minus, so 4 times 1 is 4, 4 times negative 1 is uh, negative 4, and then we have minus negative 4, so 4 plus 4, we end up with just 2 plus or minus the square root of 8, all of that over 2, right? And we can reduce or rather we can factor that radical expression. So now we have x is equal to 2 plus or minus. That would be 2 square root of 2, all of that over 2. And we see we can cancel all of these 2's here because all three terms in this rational expression have a GCF of 2. And we reduce by 2 and we're left with simply 1 plus or minus the square root of 2. Okay, so my two solutions, one solution would be 1 plus the square root of 2, right? Which would be about 2.414. So we'll say about 2.41. And the other solution would be equal to 1 minus the square root of 2, right? So 1 minus the square root of 2. That one I'm not sure about off the top of my head. It would be negative 0.41. Okay. Simple enough. So let's do a more complicated example. And after the second example, I'll probably call it quits because there's not really a whole lot to this. It's just putting the numbers where they belong. Um, and I mean, you could argue, well, maybe not that one. Let's do which one looks the ugliest. Let's do number 4. So you could argue like there is difficulty when you have to simplify in the radical expression, but I mean, we're going to be limited in that, depending on the context of the problem. Okay, so we have got 4x squared minus 12x equals 15. Again, we are not in standard form, so we're going to go ahead and do that. So 4x squared minus 12x minus 15 now equals 0. We are in standard form. We're good to go. X is going to be equal to negative b, so negative negative 12 is just positive 12, plus or minus the square root of b squared minus 4 times a times c. All of that over 2 times a. Okay, so now, again, we're just simplifying. This is going to be 144 minus, so 60 times 4, so it's actually going to be plus 240. Okay, so 15 times 4 is 60, and that's negative 60. Negative 60 times negative 4 is positive 240. And we combine those two into 384, so square root of 384. All of that over 2 times 8, which is 16. And I'm not even going to bother having you try to factor out the square root of 384. The heck with that. So from that, we're going to get one of our solutions is going to be 12 plus or minus the square root of 384. And I'm saying plus or minus. We're going to be absolute here, be specific. So one of our solutions is going to be the plus, the positive one, right? And when I throw that in the calculator, let's see what we get. So square root of 384, that's about 19.59 plus 12 divided all by 16. It's about 1.97 when we round to the nearest hundred. Then our second solution is going to come from 12 minus now the square root of 384. All of that divided by 16. So again, square root of 384 is about 19.60. And we're now going to take that away from 12. So that gives us negative 7.59. And we divide that by 16, and we end up with negative 0.47. Okay, and that's all there is to using the quadratic formula. Really simple. And I guess I'll save the discriminant part for another video, but I guess I can go ahead and squeeze in here what the answer in number 6 would be. So b squared minus 4ac. That's this stuff right here in the radicand, right? So the radicand is the stuff that's under the radical, under the square root or cube root or whatever it happens to be. So that b squared minus 4ac, we call that the discriminant. Okay, and I'll get into that in another video here in a second. But whenever b squared minus 4ac is less than 0, we get, can't spell, we get non-real answers or solutions or roots or x-intercepts or whatever. Okay, and I will go over that a little bit more in depth in another video. Okay, goodbye.